To wrap up, let's go back to the start and think about programming paradigms and see where what we've learnt fits in. Programming paradigms represent different views of how software is created. Each paradigm brings its own set of artifacts that helps us shape the way we think about how that program works. These are really the tools that we start to work with as we write code in that language. So obviously, if it's got different sets of artifacts, we're going to think quite differently about how we put our programs together, even though they all run effectively on the same machine. Picking up a new programming paradigm is therefore much harder than picking up a new programming language. Picking up a new programming language in a paradigm that you already understand is a relatively easy task. It will take some time, but there won't be any new big challenges usually. However, picking up a new programming paradigm is much harder. This is where you've got to think differently about how you organize your software. But by mastering a range of programming paradigms, you'll have much greater capacity to match the solution that you want to create to the problem that you've got. So when we have a problem, we can say that problem is going to be solved really nicely with this way of thinking about my software, rather than always having to approach them in one way. The way that we've been learning is sort of very much tied with the actual hardware itself, but there are other different ways of thinking. The key bit is that the computer itself doesn't change. So we can still do the same kinds of things, the same capabilities, it's just how we view the structure of the solution. What we've been doing is procedural programming, and it's sort of founded in the imperative programming style. So this is the style of programming where we give commands. We say, do this, then do this. Now do this instruction. And the instructions run in sequence with the ideas of sequence selection and repetition from structured programming, and then functions and procedures to organize those sequences. So with imperative programming, we're commanding the computer. Now in this style, we have variables in order to store values. And we can manipulate the values in those variables using things like the assignment statement, and then reading those values back at a later point in time. Now this foundation is very useful for learning most of the other programming paradigms. So that's a really good basis to start from. As this sort of many languages are related to the imperative programming paradigm. One of the next ones that you'll look at is the idea of object-oriented programming. It builds upon the ideas of procedural programming with an extra idea of objects. The ability to create entities that know and can do things in your code. So something a bit more complex than the structs we've been working with and the functions and procedures. Something that combines those two aspects together. Rather than seeing our program as a hierarchy of functions and procedures that call each other and data that is organized in structs and enums, etc., object-oriented programming looks at it as a network of related objects. So we have a number of objects that are all related and they interact with each other in order to perform system goals. You can think of it like little actors in the system where each is performing a role and they interact and talk to each other in order to get system tasks completed. Things are still running in sequence selection and repetition, and so an actor performing the roles is still just executing a sequence of instructions. But we try to think about it at that higher level. So the instructions are still imperative, but they exist within a network of objects. Many of the web and mobile application development platforms are built around the object-oriented programming paradigm. So now that you know procedural, learning object-oriented programming is the next obvious step. But there are other programming paradigms that help us build different kinds of solutions depending on the area. One kind of programming paradigm is what's called the declarative programming paradigm. Here you don't say how to do something, but what you want to do. Languages like SQL, where you say, select this data from that table. You don't tell it how to do that, you just tell it what you want. I want this data from that table connected in this way with only the values that match these expressions. It then works out, okay, how best to read the data off the disk, how to organize it, connect it together, filter it, etc., and get it back to you. Same with HTML. We don't tell it necessarily the instructions to draw each thing on the screen. We just say, I want a div here which has a header inside it and a paragraph with some bold text, etc. So HTML and SQL are declarative programming languages. We say what we want, not how to do it. The other programming paradigm that we care about is the functional programming paradigm. Functional programming paradigm is based on a more mathematical way of viewing our software. This removes the idea of state. So variables are not something that really exists within a functional programming paradigm. Instead, we look at modifying the state of things as they go around through functions, things that execute and manipulate data. It's a different way of thinking, and it probably requires the biggest step away from imperative programming. But it is a very useful paradigm which can be used to create a number of things. In addition to that, we have the idea of concurrent and parallel programming. Concurrent and parallel programming is all about getting the computer to do more than one thing at a time. This works particularly nicely with functional programming because there's no manipulation of state. It means we can easily parallelize things. Things can run in parallel because they don't depend upon each other. But concurrent and parallel programming is also another area that's definitely worth looking into. Now, will you be able to take advantage of these different programming paradigms? At the moment, we've got the idea of the structured procedural programming paradigm. The key bit is to realize that there are other paradigms that enable you to think differently about how your software works. Learning each of these programming paradigms will help you understand different ways of solving your solution. Remember that the computer itself doesn't change, but we can think differently about how we structure our software solutions. Programming paradigms really give you the opportunity to try different ways of doing things. Fortunately, there are different units you can study in order to explore these different programming paradigms. So the next obvious unit would be the object-oriented programming unit. Once you've done that, you can go and look at things like data structures and patterns, as well as web programming and programming iOS, Android applications, etc. They all build upon the object-oriented programming paradigm. We have another programming paradigms unit itself, which is dedicated to exploring different paradigms. Now that you know the procedural programming basis upon which most things are founded, you'll be set up to get started with these different paradigms. Good luck with that.